Welcome to lesson 5.3. We're going to be talking more about inscribed angles. Now, we started talking about those in lesson 5.2, but now we're about to take it to the next level. So I hope you're ready because it's about to get fun. All right, to start off, we're going to talk about inscribed triangles. Now, what does it mean to be an inscribed triangle? An inscribed triangle is a triangle where each vertex of the triangle touches the circumference of the circle. So let's break that down. Now, a vertex is where the angles of the triangle are. So these are all my vertexes. All right, so this is a vertex, and guess what? This is a vertex. And since they all touch the circumference of the circle, which is the circumference is just the outside of the circle, then we know this is an inscribed triangle. So we got one right here. All three angles touch the circumference. Now here's a fun fact. If a triangle is inscribed in a circle and the hypotenuse is the diameter, so like right here we see the hypotenuse is the diameter of this circle, then the triangle is a right triangle. Okay, this would be a right triangle. This is a 90-degree angle. Now how do I know that? Well, if you remember from the last lesson, the angle, the inscribed angle, is always half of the arc it intercepts. So if this is the diameter, then I know this arc is 180 degrees, right? It's half the circle. The diameter splits the circle into two, so this is 180 degrees. If the arc is 180 degrees, then I know the angle right here, this angle right here, see, this is that intercepts the arc, must be a 90-degree angle. So this angle A is 90 degrees. Okay? That's the big thing. If the diameter is the hypotenuse, then it's a right triangle. This is a 90-degree angle right here. So let's see how we can use that to our advantage to solve some problems. Well, in this problem, AB is the diameter of circle E. All right, this is circle E, and AB is our diameter. We know angle B is 42 degrees, so let's fill that in. All right, we want to find the measure of angle C and angle A. Well, how can we do this? Well, here's the thing. If this is our diameter, then we know angle C is a right angle. This is a 90-degree angle. Okay, we could even write that in. So to find out what angle A is, well, remember there's 180 degrees in a triangle, and if we subtract the two angles, we get the third angle. So we could just say 180 minus 90 minus 42, we just subtract two angles, gives us our missing angle. So if we do that, we should get 48 degrees, like so. So angle C is 90 degrees, and angle A is 48 degrees. And our three angles, 1, 2, and 3, they all add up to 180. Beautifully done. So if the diameter is the hypotenuse, then we know that this is a 90-degree angle, or a right triangle. All right, let's try this again. EF is the diameter of circle D. If we know E is 57 degrees, so let's fill that in, find the measure of angle G and angle F. Well, once again, since this is the diameter, we know angle G is a 90-degree angle. Since angle G is a 90-degree angle, and we know there's 180 degrees in a triangle, we just do 180 minus 90 minus 57. And what do we get? We should be getting 33 degrees. All right, fill that in. And so angle F is 33. All right, you might have some more problems to practice on with this. You should be good to go. All right, so now we're going to talk about inscribed quadrilaterals. Now, if you don't know what a quadrilateral is, that is any shape with four sides. All right, a quadrilateral is any shape with four sides. And just like with a triangle, an inscribed quadrilateral is where each vertex of the quadrilateral touches the circumference of the circle. So this is a vertex, this is a vertex, this is a vertex, and this is a vertex. See, those are my vertexes. And they all touch the circumference of the circle. Now here's a fact. If a quadrilateral is inscribed in a circle, then the opposite angles always add up to 180 degrees. So what that means, what I mean by opposite angles, well, we could say that A and B, those are my opposite angles. So A plus B, that would be 180 degrees. And then if you look over here, we have C and D, which are opposite from each other. C and D, I'll just use different markings here. These also add up to 180 degrees. So the opposite angles always add up to 180. Now, there's a little bonus here. If you could come up to me and explain why this is true, well then, I don't know. You're just awesome, because I'd love to see someone do that. Explain why this fact is true. Opposite angles add up to 180. Think about it. It has to do with inscribed angles. So how can we apply this? Well, let's try our first one. Quadrilateral WXYZ is inscribed in circle V. Let's put a little dot there. Okay. If angle W is 102 degrees, which is right over MIA, what is the measure of angle Y, which is across from it? So these are opposite angles. Well, to figure this out, all I have to do is know this. I know that these two angles add up to 180. So let's put an X here. And so we could just say that 102, which is angle W, plus X equals 180 degrees. So I just subtract 102 from both sides. I get X is equal to 78 degrees. So angle Y is 78 degrees. Now another easier way to do that is just to do 180 minus the angle you know. So 180 minus 102 equals 78 degrees. So angle Y is 78. Two ways to do it. You can set up your equation 102 plus X equals 180, or you could just do 180 minus the angle you know. I prefer doing it this way, just a little easier. Let's try one more. We know quadrilateral LOVE, see, that's cute, is inscribed in circle T. If angle O is 86 degrees, let's put that in, and angle V is 93 degrees, we want to find the measures of angle L and measure E. And remember that M just means measure. What's the measure? Okay, so all we have to do is find the opposite angles. We know L and B are opposite. So to find out what L is, we just do 180 minus 93. They're opposite from each other, and that will give us 77 degrees. So that gives us L. And to find out what circle E is, well, once again, we just do 180. And let's see, opposite of circle E is O, so minus 86. And that gives us 94 degrees. All right. Now, if you want to check to work to see if you did everything correctly, all four angles should add up to how much? Well, remember, quadrilaterals always have 360, so you should add these four up and get 360 to see if you're right. You could check to see. Maybe I did something wrong, but I'm betting pretty good that I did it right. So for our final part, we're going to be doing inscribed angles that intercept the same arc. All right? Well, we know here that angle B and angle D both intercept AE. Now, that's kind of tough to follow, so let's use a highlighter. Angle B is right here, and that's composed of this line and this line, right? So that intercepts the arc. Well, let's use a different color. Let's use pink. That intercepts arc AE. Now, angle D is made up of this line and this line, right? And that angle also intercepts the same arc right here. You see, angle D intercepts arc AE, and angle B intercepts arc AE. Since these two angles intercept the same arc, we know they are always going to be congruent. And that makes sense. If they intercept this arc, then the angle should also be the same. So we know angle B is congruent to angle D. All right, you got me there? Doesn't that make a lot of sense? Let's try, but there's also more angles that intercept the same arc. So I'm just going to erase this. Okay, let's start this over. I know angle A and angle E both intercept arc BD. Now once again, let's take out the highlighter. Angle A is right here, and that's made of this line and this line. So this is our arc BD that it intercepts. That's so ugly. And then we have angle E right here, and that's made up of this line and this line. And once again, this intercepts the same arc. And since those two angles intercept the same arc, I know that angle A is congruent to angle E. Okay. It's kind of tough to follow, I know, but the highlighter really helps. You should take one out if you're not fully seeing it. So let's take a look here. In triangle ABC, which is right here, we know angle B is 35 degrees. Okay? We want to find the measure of angle E, which is over here. Well, let's see here. If you look at this, we see that angle E intercepts the arc here, FA. And we also know angle B, which is right over here, intercepts the same arc. Since they intercept the same arc, we know they are congruent, so angle E is also 35 degrees. See, they both intercept this arc. Now for our next one, this gets a little more complicated. We want to prove that triangle DEF, which is right over here, is similar to triangle NMF. Now that's kind of funny, right? We were just talking about angles being congruent, and this similarity stuff, that's all from angle, this is from level 2. But I'm going to show you how we can do this. All right, we can do a proof here. Check it out. Well, let's look at this arc over here. So first, let's start with our arc right here. This arc right over Mia. Why is that so ugly? Jeez, that's the ugliest thing I've ever seen. It's uglier than your mom. Oh, snap, I just got you. Whoa, anyway, so this arc right here is, you know what, let's do it in purple. I want to stay consistent. Okay, we got our arc right here. This arc right here is actually intercepted by two angles. We have angle E that intercepts this arc, and I have angle M that intercepts this arc, right? These two angles both intercept this same arc right here. So I know that angle E and angle M are congruent. So let's mark that. Angle E is congruent to angle M. Now the second thing I know is that I have, well, let me erase for a second. Okay, so let's get this out for a second. Ooh. Okay. Angle E is congruent to angle M. Now I also know over here that angle D, which is right over here, intercepts EM. And I also know EN also intercepts that same arc. So since those two angles intercept the same arc, they're also congruent. So this angle is congruent to this angle. D is congruent to N. So since I know that angle E is congruent to angle M and angle D is congruent to angle N, I actually have angle-angle similarity. Remember, angle-angle similarity. So I could say that triangle DEF is similar to triangle NMF because of angle-angle similarity. See that? We just got smart on that. So that's it for this lesson. My suggestion to you guys, watch this video twice if you didn't get it, maybe 3 times, or maybe you just did get it. Hey, Kitty, stop that! And then go and hug your mom. Kitty! Peace.